Hello, my name is Nico Geraldo, and this is Lab 3, Magnetic Field of a Bar Magnet. Purpose of this lab was to measure the distance dependence of the magnetic field due to a small bar magnet, and compare my measurements to the distance dependence predicted by the equations for the on and off axis magnetic fields derived from the Biot-Savart law. The main principles I used were the Biot-Savart law and the distance dependence formula of a bar magnet. The results of this experiment were the magnetic dipole moment was 2.606 ampere meters squared, and n was -3. The experiment's details. For the model, the bar magnet acted as the magnetic dipole. The initial conditions were a bar magnet and the phone magnetometer. System was a bar magnet, and the surroundings were everything else. The procedure. First, I had to align the meter stick with the magnetic north pole of the Earth, so then it wouldn't interfere with the magnetometer's readings. Then I had to find the location of the magnetometer in the phone by placing the phone on a meter stick perpendicular to uh, or the phone perpendicular to the meter stick, both horizontal and vertical, with the bar magnet at one end of the meter stick. Then I had to slide the phone across the meter stick to find the highest reading from the magnetometer from the bar magnet and place tape to mark the position of the highest reading. After finding the location of the sensor in the phone, I had to move the phone off the meter stick and record values for dperp and the magnetic field at that location to get the off-axis values. These are the data from the spreadsheet, and this includes the linearized table. Data and calculations, the distance dependence equation, this is the linearized equation, is -3x minus 14.467. N is just going to be the coefficient of x in this scenario. ln of course, is the -14.467. K, after some rearranging, is equal to 5.21 e to the -7. R is just going to be 1 in this case, and from rearranging the equation, I could find that the mu is going to be 2.606 ampere meter squared. This is the glow script code. First, I had to make a magnet by just making a little cylinder at the origin. And then I added a little bit to the dipole function. After that, I made some observation location vectors and magnetic field vectors for on-axis and perpendicular. And then after that, observation and magnetic field vectors for the off-axis. And then this is the simulation from running the code. For the discussion, experimental magnetic field was 1.73 e -4 Tesla, and the theoretical magnetic field was 3.26 e to the -5 Tesla, which gave me a difference of around 530%. So that's not very good, but the model is fine. The bar magnet represents the magnetic field of a dipole very well. But I had a couple of errors. Some error sources were not finding the exact location of the magnetometer and not correctly aligning the phone with the Earth's magnetic field. For my what if questions, what if I hadn't oriented the experiment to compensate for magnetic north and it had instead laid out my meter stick at some intermediate angle with respect to the Earth's magnetic field? How would your results have changed? The Earth's magnetic field would have interfered with my readings, and I would have had to account for it in my calculations if I knew the angle. But if you were to stick two identical magnets together end to end and run the experiment again, how would you expect your measurements to differ? The direction of the field would stay the same, but the magnitude would be around double.